Compound A contains a tetrazole ring, and this is compound A. It contains a tetrazole ring, a 5-membered ring containing system that contains 4 nitrogen atoms. While its constitutional isomer is compound B, which is this, and that exhibits an azido group. This is the azido group. There is evidence that compounds A and B rapidly interconvert, which means they are in equilibrium and they switch between the two structures, and they are in equilibrium with each other. There is only one nitrogen atom incorporated in a ring in compound B. So this is B, and there is only one nitrogen atom that is part of the ring, whereas A has more than one nitrogen atom that is part of the ring. So draw arrows to show how the interconversion takes place. So go ahead and pause the video, solve it, and start when you're ready. So if you look at these two structures, it's easier to start with the open ring and push and pull arrows, electrons using arrows to draw the other structure. So if you look at all these nitrogens here, this nitrogen with the negative charge is going to have 2 lone pairs. They all have the right number of bonds and they all have octet. And nitrogen with 4 bonds is going to have positive charge. Nitrogen that is neutral, they are going to have lone pairs, and the nitrogen that has negative charge is going to have 2 lone pairs. And as you can see in these two structures, there is a double bond here, whereas there is a single bond between those two same atoms here. Okay, so it's always easier to number them. So 1, 2, 3, 4, 5. Therefore you have a 5-membered ring. Okay, and as you can expect, these two nitrogens are the ones that are going to make a bond. So this is 1, 2, 3, 4, and 5. So atom 1 and atom 5, they are making a bond, which means you have to take these electrons and move that towards nitrogen 1, and nitrogen 1 already has an octet, 1, 2, 3, 4, 5, 6, 7, 8. So it cannot accept a bond electron unless it lets go of the other bond on the other side. So these electrons can move here between the two nitrogen atoms. This nitrogen atom also has an octet, therefore it has to let go of one of the bonds on the other side, and that is going to be the breaking of this pi bond, and the nitrogen here with the positive charge gets these 2 electrons as part of which becomes its lone pair, and it also ends up losing its positive charge because it has gained 1 electron overall, and this nitrogen loses its negative charge because it is losing 1 electron overall. Okay, and therefore from here you can draw the other structure. And if you want to know whether the other compound, the new ring that is formed, if this is aromatic, we can look at the number of electrons. So 1, 2, 3, 4, 5, 6. These 3 pairs of electrons, 2 bond pairs and 1 lone pair, they can go into conjugation in a completely cyclical manner, and that can lead to an aromatic system. So yes, tetrazole rings are actually aromatic, and there is a lot of evidence to that effect.